Good evening friends. In this video we are going to understand about how to use the Adaboost as a classifier. So for this purpose what we do is first step is to choose the best decision tree stump. Best decision tree stump. Okay. Suppose we have a data set which has some independent features A and B and it has some output features. Okay. Suppose there were some conditions and here also some of the values and here were the binary classification like 1 0 1 0 1. Okay, so what will happen that I will make a decision tree sum on the basis of A feature also and the basis of B feature also, and I have applied some condition or threshold condition. Like suppose my A was a numerical column and applied that all the values greater than 2. So the values greater than 2, a node will be created here, and the values less than 2, a node will be created here. Similarly here for B, suppose I have a categorical column and I choose that if the value is B, then the values will be the values with not B, and we will see that suppose here it was 2 yes 2 no, and here it was 2 yes and 4 no. In this node there were 3 yes and 0 no's, 1 yes and 3 no. So to choose the best decision stump, what we will check, we will check our entropy and Guinea impurity, entropy and Guinea impurity, and the information gain. On the basis of these three factors which I have already discussed with you, we will select the best decision tree. What do we mean by entropy? Entropy means the impurity present in the particular node. Information gain mean what? Information gains means if suppose a parent node has an impurity of x and if my children are having the impurity of y, if my y comes to be smaller than x, then yes, this is a good split. And entropy and Guinea both are impurity. This is the information gain which is used to check whether our split is best or not. Now what will happen is that we have chosen our decision tree stump that will be done on the basis of this because it is having the most information gain. Okay, now what we will check is that suppose we train our decision stump on this data set. Okay, initially what will happen, initially I have my A B output and sample weight. Suppose initial sample weight, I have already told you that at the initial state we assign equal weights to all the records, so my model focus on all the records equally. Now suppose I have 7 points here and 7 points here, so weights will be what? 1 by 7, 1 by 7, 1 by 7, 1 by 7 and 1 by 7. Okay, are you clear with this? Here I have 1 2 3 4 5, similarly 2 more will be there. Okay. So now suppose my model has made one of the predictions wrong. Suppose this was the value where my model predicted it wrong. So our next step is to calculate the sum of the total errors. Our step is what? Sum of the total errors. So in the sum of the total errors, what we do is we just do nothing but on the numerator we write that how many data points our model predicted wrong. It is only 1 divided by total number of data points, that is 7. So this will be my sum of the total errors. Now till here we have got our sum of the total error. Now what I will do is we will check the performance of this term, like the performance of my first weak learning model, and the formula for this is 1 by 2 ln 1 minus total error divided by the total error. Okay, when you will substitute the value in place of total error, you will be getting some value. Like suppose it was coming out to be, I have not calculated it, but suppose it came 0.5. So this will be what? This will be the performance stump for my first model. And we know there is a formula for our Adaboost function, that is alpha times of model 1, alpha 2 times of model 2, alpha 3 times of model 3. Similarly, how many models that we make. And here for each decision stump, the performance stump value is the alpha value for the model. So for the model 1 it will be this. Now we are clear with the first model, that first weak learner. Now we'll be moving towards the second weak learner. So I have already told you that while moving to the next model, next weak learner model, we first update our weight. So we have our two data points. First is the correctly classified data point, second is the incorrect classified data point. So for the points which our model make correct prediction, its formula will be its old weight multiplied by e to the power minus times of performance of stump. Okay. And for the incorrectly classified points, its weight form updated weight will be this into e to the power performance of stump. Okay, so what will happen again? My A feature, B feature, output feature, and then my weight was there. So now here was my some incorrect classified point. So I will update whatever value came from a like x, and all the other place y and y. So till here I have done the updation of weight. Now what I will do? Okay, so we are clear till here. Now what we will do, if you will observe, there is a problem that if we sum all the updated weights, the sum is not coming out to be 1. But initially if you have seen 1 by 7 till the 7 values, the sum was 1. That is a required thing. So what we do is that we normalize our weights. We normalize our weights. And for normalizing our weights, what we do is that we first of all find the sum of these updated weights, and for each updated weight, for normalizing it, we will divide the updated weight divide by the sum of the updated weights, and then this assign another column, that is normalized weight here, which will be having the normalized weight for each of the rows. Okay, now after normalizing weight values are assigned, we make the bins. Bins are the values, bins are the range from for each of the cell, and you will observe that for the incorrect classified data point, the bin size is the greatest. And now for choosing what data we are going to pass to the next model, our model makes a iteration for loop, and then it gets some random values, and most of the values lie in the incorrect sample. Like here I have only taken one incorrect sample, there will be lot more incorrect sample in the real world data set. So what will happen, when our model will be applying a for loop internally and choosing randomly some data records, most of the data records are chosen that are predicted wrong. Now these data points are passed to our new model, that is model 2, and now the same step is followed which I have told you. Again the weights will be updated, again the weight will be normalized, again the bins will be created, again the what we have to pass to the next weak learner is selected, and the same process goes on.